afternoon. Today we welcome you to the another lecture in the course of Applied Analytics, and we are continuing in this course in the way of understanding the need for a rational decisions and how analytics, both the descriptive, prescriptive, and as well as the latest advanced predictive analytics, how it actually helps in a decision maker to make the right decisions for the organization. And today we are going to get into the concepts of systems, models, and the modeling process. We will look at a brief overview of this, and then we will take the much advanced stuff. So today we are discussing systems first in a brief way, then models, and then the modeling process. Okay. And I am Dr. Deepu. I am from IIT Kanpur. So let's talk about the first thing called system. Now there is lot many ways people think about system. So I would say the first thing is system word. The word system, okay, is one of the most misused words in let's say that's in the world for the time being. Okay. There are many understandings and other things about it, but in our case today when we are talking about system in the phrase of analytics, in the context of analytics, we can derive system. Okay, we can describe system. Okay, let's describe system as a set of interrelated elements that function in a purposeful manner. This is what Watson and Blackstone kind of said it in 1981. So system, the main aspects of a system is, okay, system has number one, many interrelated elements. Some people would like to call this as entities. Okay. These typically include man, machine, money, methods, etc. These are all parts of the interrelated elements of a system, and all these interrelated elements, what do? They work or they function in a manner, in a purposeful manner, or in a better way to say, this goes towards a common goal or common goals. So system has common goals in which all the entities of the system or all the interrelated elements of the system work together to achieve that goal or the goals. Okay. So obviously system, the first important thing is the system has more than one element. Okay. This is one thing that we all should understand. System with more than one element means it is typically a set of elements. Okay. Let's think about it as a set of elements, more than one element. Okay. And these set of elements that are, these elements are interrelated. Okay. They are connected to one another. Okay. So when we saying that connected with one another, okay, this is the important aspect of the interrelation. These elements of the system, they are connected with one another, and these elements interact with one another. So they are interrelated, and they also interact. So one way to think about it is they are interconnected and work together. Okay. Why do they do all of these? To achieve the common purpose. Okay. So all these elements, these interrelated elements that interact with the one another. The reason these interrelated elements interact with each other is to achieve the common purpose or the common goal. Okay. So as I said earlier, system behavior, always remember this, system behavior is purposeful. system behavior is purposeful, which also means that this implies what does it commonly means? It is a goal seeking behavior. It moves towards a common goal. So, the goal seeking could be more profit, okay, more economic development, and okay, it could be better efficiency, etc. So, this goal will remain common, multiple goals, it can be different type of goals, but the system will typically work towards a common goal. That is the most important aspect of it. Now, if you draw a system diagram, if we diagram a system, there are many ways people diagram the system. And one of the diagram that I like the most, which was originally proposed by Watson and Blackstone, is system is, you can think about it as some value addition, some transformation, value addition slash transformation happens, okay, process happens. So, there is some process involved. So, you have something called as inputs, you input various aspects into the system. These inputs go through what we call as processes, okay, and these processes will provide you what we call as outputs. Okay. So, once we say that these are the aspects of the system, I am going to change the color to show you something else. So, the inputs, the processes, the inputs will result in processes, will result in output. From here, it could also have something called feedback, which you could go into. So, what we call as the feedback. So, the output will tell, okay, this output was in as per the requirement, or it was not as per the requirement. So, if the processes need to be changed, it will change the processes, or if the inputs need to be modified, it will modify the input. Then along with this, we will also have what we call as the boundary of the system. So, if this is what we are focusing on to study the system, then the rest of it is what we can call it as the, this is what we call as the boundary, okay. And through the boundary, the system will interact with the what we call as environment. So, everything outside the system boundary is the environment. So, in our case, what we are basically focusing on is the system where the inputs gets translated to processes, the inputs is supplied to processes, and these processes translates the inputs to outputs. During this process, we have feedback, and the feedback can at times go to the feedback is provided after the output to the processes. Yeah, so, if the thing can be addressed in the processes, it will use here, otherwise it will go to the inputs, and the system has its own boundaries, what we are talking about. And these boundaries is like, this is where within the boundary is what we define to study the system, and everything outside the boundary is the environment, and systems interact with environment at boundaries. So, the boundaries are the place where the systems interact with the environment. Hope this is clear. So, we will go to the next concept. So, we talked about something called as a feedback in the system, okay, and feedback, lot of the time people sometimes use feedback is sometimes used or considered as a control aspect, okay. This is not true for us. Feedback is not just, this is not always true, okay. Here we are talking about feedback in a sense that all the system, okay. So, what we talk about feedback? So, feedback for us, for analytics, if you are considering analytics, feedback involves what do we mean by feedback? It involves monitoring the actual behavior of the system, the actual behavior of the system. Okay. We are studying the actual behavior of the system and comparing this behavior, okay. Whose behavior? System behavior. Okay. This behavior of the system, it is compared with this behavior and comparing this behavior with standards. So, if you have a standard or you have an expectation that the system should behave in this particular fashion, then we use this to basically establish, we monitor the actual behavior of the system, and using this monitoring we actually compare the actual behavior of the system or the current observed behavior of the system is compared with the standard to see how the system is working. So, all well conceived systems will contain feedback loops. So, it allows for what we call as monitoring and comparing, or you can also call it as standardizing the system. Monitoring and comparing of systems is done very well through using feedback loops. It can be used for control, but it can also, there is no rule that it should be used for control. So, what does the feedback involves? Okay. So, what happens is what happens in feedback? Okay. So, as I said earlier, what is the major thing in feedback is it involves monitoring the behavior of the system, monitoring the actual behavior of the system. Okay. This we all know, this is the monitoring the actual behavior, and compare with standards. Compare with standards what? Okay. Actual behavior. Okay. You has compared with the standards. So, what now? If necessary, take corrective actions. Okay. So, sometimes this taking the corrective actions falls under the realm of controlling the system, and hence sometimes people say feedback is also another way of controlling the system, which in some cases it is true, but it is not always true. Okay. Remember that. Okay. So, then when you find deviations, what happens when you find deviations in the performance? Okay. When deviations in the performance of whom? When deviations in the system performance deviations. Okay. If you find deviations in the system performance, what are you going to do? Okay. So, from where do you find the deviations? Obviously, these deviations are from the standards. You find some deviations from the standards or the expected performance on the system. What do we do? The most important thing is transmit such information. What information? The deviation from the standards. Such information to where do we transmit to? Appropriate locations. Okay. Appropriate point in the system. Appropriate point in the system. So, in the previous diagram we have seen that we are transmitting this to the process level or to the input level, appropriate point in the system. Why do we transmit this? So that effective action can be taken. Right. So, when you find that the system is deviating, when deviations in the performance from the standard is noted, transmit that information to appropriate point in the system, so that corrective actions can be taken. That is one important aspect of feedback in the system. And also you should remember that most systems are not self-contained. Okay. When we say that a system is self-contained, what do we mean by it? Okay. What do we mean? What do we mean by self-containment? Okay. The self-containment means self-containment implies system working in isolation. Okay. So, which implies isolation means isolation with the external environment. Many people would like to do this, but the truth is that okay, most of the time system is influenced by its environment. This is very important. You should remember this, that the system is influenced by its environment. Very rarely you get systems that are isolated, self-contained system. Most of the systems are not self-contained. They work in tandem with the environment, where the environmental factors, the factors that are outside the boundary of the system, do have its influence onto the system. Okay. With that, we talked about the concept called system boundaries. Okay. And we like system boundary, we have been repeating this term. So, what is a system boundary? Okay. So, remember, if you think about the diagram, we draw kind of this is the inputs, from there we drew the process, then we draw the output, okay, and then we had feedback loops and other things, okay, which went like this as the feedback. Then we drew the boundary, okay, an imaginary kind of a concept, okay, and then we said it interacts with the environment here, and we called it as a boundary. So, boundaries are never really a rectangular boxes. Okay. Boundaries are not, this is important, not rectangular boxes. Okay. We just draw it for a representative purpose. It is like, so it actually it represents the part of system that is being studied. Okay. The important aspect is that it represents that part of the system that is being studied. So, the major reason why we do the boundaries, okay, why are system boundaries used? They are used to establish for modeling purposes, because when you are modeling, you do not want to study the entire system, you do not want to study the system and its environment, you want to focus your studies. So, system boundaries helps to define or focus the study. In our case, instead of the study, it is the analysis. So, we focus our analysis on the system using the help of system boundaries, and hence once you establish the boundaries, then you can, using the boundary, we can model the behavior of the system. So, what are we modeling here? What are we modeling? We are modeling the system behavior. System behavior within the specified boundary. All right. So, we are studying this within the specified boundary of the system, and it is difficult to design. Okay. So, we can always, and you should understand that system boundary, it is quite difficult to establish. Okay. So, or it is difficult to establish or determine. It is not just difficult, it is quite difficult to establish or determine to what level of detail the analysis should happen, analysis to be done. Okay. So, this is a major question, difficult to establish or determine to what level of detail the analysis is to be done. So, the boundary do help us in focusing the decision or focusing the analysis, but yes, it is difficult to draw the boundary. Why? Number one reason. Okay. The reason is most of the systems are made up of many subsystems. Okay. Because for example, let us take an example, a manufacturing system or a production system. Okay. A production system has many subsystems. One is the inventory or the stores, okay. It is an assembly line, okay. Painting, so many aspects are there. But at one aspect of it is also that there is also something that you require an electrical substation. Okay. So, now the question is this electrical substation part of the system, is within the boundary or outside the boundary. So, it is a subsystem of the production system, but it can be sometimes treated as a part of an outside system or the environment, or it could be treated as part of the internal aspect as well. So, because of these many subsystems, so if your study is only focused on line balancing the assembly line to decide how fast the conveyor belt of the factory should move, so that the desired production can be reached. If that is a focus point, then studying the electrical substation is outside the boundary of the system. But if you are studying how to achieve the production with minimal use of energy, then the electrical aspect is part of the system. So, depending upon the study, so this also tells us that boundary is specified by goal of analysis. Okay. This is an important aspect. Okay. Second part is most systems are subsystems of large systems. The second reason why this becomes drawing this boundary is a big problem. Okay. So, like for example, let us say you are studying the Maruti factory in India. Okay. This could be treated as a system if you study the Maruti Suzuki factory in India, but it is also a subsystem of the subsystem of the global Suzuki factories. So, the system that we are studying here in India as the Maruti factory is actually a subsystem of the global Suzuki factories. So, the system that we are considering at one point of could be a subsystem of someplace else. So, when you have subsystems, then we get into this problem called, if you study just focus on the optimization or making the Maruti Suzuki factory in India as the best factory, then all you are doing is you are not making Suzuki the best thing. You will end up doing something called as sub optimization. All system studies, all analytics do suffer from this problem. We will see this in the complicated problems, but remember that a system that we are studying today could be very well be a subsystem of something else. Third part is system tend to interact and overlap with other systems. So, here what we are saying is that an example is the marketing system of a company sometimes tend to overlap with the production system, sometimes overlap with production. How? In what we call as setting the demand. So, the marketing people are the one who tell what is the demand for a particular product. Once you know what is the demand for the particular product, that is when the production department decides how to produce or how to fulfill that demand. So, that is the place where the marketing system interacts with the production system. But there could be other situations where production system is trying to figure out what is the line balancing, or what is the optimal speed of the conveyor belt, or which tool bit to use to drill this particular hole. They do not need to interact with the marketing system at all. Okay. Last aspect of this is the necessary linkages with that of the environment. Okay. Many a times these linkages, okay, are complicated uh, so that even with clearly defined boundaries, okay, uh, some aspects could be overlooked. Okay. So, the because lot of the things, the environmental factors, do influence system. A classic example of this is the price of oil set by the OPEC countries do influence the quota of production of petrol and diesel from the Indian oil companies. Indian Oil Corporation, Bharat Petroleum Limited, they all decide their production and other aspects depending upon the price of the oil set by the countries in the Middle East. So, that is an environmental factor. The price set by the OPEC nations is an environmental factor which influencing the internal aspects of the system. Let us say if you are studying the IOCL corporation as an example. Okay. So, it is not straightforward in that regard, but yes, it is the reason the system boundaries are difficult is because of all these kind of different considerations. But still you have to do the best as you can to define the boundary of the system, so that you can do some sensible analysis out of it. Then let us talk about models. Okay. The models is in a way in this, it is a word that is very complicated, but still in the most simplest terms, what is being simulated is the system, or what is being, instead of using the word, let us study what is being studied or what is being analyzed. Okay. The simulated might be a wrong term here. We will say that what is being studied or analyzed is a system, whatever you are studying. Let us think about it that way. Okay. What you are studying is a system. So, so in this case, an example of a system will be, if you are looking at how much of the product to be stored, how much of raw materials to be stored, This focuses on the inventory system. So, the inventory system might not be something that you might not study otherwise if you are worried about the raw materials to be stored. Okay. And how does that influence the rest of the system? That is a completely different story altogether, but yeah, you probably get an idea. So, if you are just studying the inventory system, then you look at the inventory model, and then you sometimes find the EOQ model, where you will say that is the root of 2 times the ordering cost times the demand divided by the carrying cost. If you might be looking at a mathematical equation like this, where you are studying the inventory, and this is the what we call as the inventory model. Okay. So, we are studying how much quantity is to be kept at one particular place, and this is the mathematical way of modeling that. So, you are just focusing on that aspect of the system. So, you just study, you are not worried about what you are storing, you are only worried about the quantity of whatever is to be stored. So, here we are ignoring what is being kept as inventory. Okay. It could be nut, it could be bolt, it could be missiles, it could be guns, does not matter. You are just worried about the inventory at this point. You are just worried about the number, the quantity, that is all you are worried about. So, to study the system, okay, assumptions or approximations are to be made. We make assumptions and approximations, both logical and as well as mathematical, how the system works. So, these assumptions to a large extent helps us in making the models. These assumptions helps us in the model or modeling of the system. Okay. So, the assumptions that helps us to form the model of the system. So, in the EOQ system, we assume that demand is known and does not change. So, we assume that the demand is known and it will not change. we also assume that there is enough space to store whatever the quantity is. So, there is no space constraint as we think about it. So, these assumptions, based on these assumptions, we study how to store some item in a factory, and for that we develop a mathematical model. Okay. So, these assumptions help us in forming this model. Okay. And why do we use models? Because we can use models to replicate the behavior of the real life system. So, in a inventory, the model focuses on the quantity to be ordered, okay, which is the Q, and when to order, which is the time. Okay. So, we are worried about the quantity and the time specifically in an inventory system, and to do that we take assumptions, and these assumptions about the system, and the assumptions helps us in forming the models. So, there are multiple types of model, and we will quickly go over these type of models. Okay. So, all type of models, let us think about it this way. Okay. All models, let us take about it, and it can be divided as far as by Blackstone and other people, it can be divided into two. One model can be called as the physical model, and the other one can be called as the symbolic models. Okay. The models can be either physical or it can be symbolic, and the physical models are further divided into two, and this is called as the iconic models, or it could be the analog models. Okay. And the symbolic models are, we will study what each one of them in detail. The symbolic models can be a verbal model, or it could be a mathematical model. Okay. So, in a way, when we talk about this, we have to study. Let us first talk about what is a physical model, that is easy to understand. Okay. Physical models are physical representation of reality, representation of reality. Okay. You are physically representing the reality of the system. Okay. Whereas, what is a symbolic model? Symbolic models use symbols to represent reality. Okay. So, an example is if you see a road sign, something like this. Okay. If you see a road sign like this, which says, okay, on a post the sign is kept someplace, then that means there is a pedestrian crossing. Okay. It is a symbolic representation of pedestrian crossing, which means ahead someplace there are people who are going to go across the road. Okay. So, that is what a symbolic example is. So, let us look into the definitions of each one of these iconic, analog, verbal and mathematical, and see what it amounts to. Okay. So, the iconic models, when we talk about it, what are iconic models? The iconic models are, they looks like represented reality. Okay. So, an example is the reality shows. So, displaying the behavior. So, here is an example, displaying the behavior of astronauts in the international space, international space station on television. Okay. This appears, this is what we call as an iconic model. It is a represented reality of what is actually going on. You are not seeing what is going on in the system, but you are actually seeing on a TV screen what is going on there. So, that becomes an iconic models. Now, let us talk about something called as an analog model. Okay. What are analog models? So, analog models, they acts like represented reality. The previous case, it looks like the represented reality. In analog model, it acts like represented reality. An example of this is a small scaled model of a fighter jet in a wind tunnel. Acts like actual aircraft in flight. Okay. So, that is what we talk about here in an analog model. The iconic model, both these cases, they are actually the physical system models. Okay. You are actually seeing the physical system, you are observing it. In iconic models, you are observing is through a television. In an analog model, you make a small model of it, and that model acts like the represented reality. So, these two together becomes the what we call as the physical models. Okay. Now, let us talk about what we call as the verbal model. A verbal model or verbal models, they are use of words to represent the reality. Okay. So, an example is, examples of these are role playing exercises, or it is the commentary of a game. So, when somebody says if we are talking about a soccer game, you can say that the soccer game between Germany and Brazil is going on, and you say that, oh, the currently the ball is being moved forward to the Brazil half by Philip Lahm or something like that. Then obviously, then you will see you have in your mind the football court, and the ball is now past the center line, and now it's in the side in which Brazil is playing, and Philip Lahm is pushing the ball forward. That's how you will look at it. So, when somebody is using words to describe what is actually going on, that becomes a verbal model. Lot of the commentaries about the game is an example of a verbal model. Then let us talk about the last one, which is called as a mathematical model or mathematical models. Mathematical model means this is the usage of mathematical symbol, numerical symbols to represent reality. Okay. So, for example, when you do an equation something like this, y is equal to mx plus b. So, in this case, x represents the slope of the line, or it actually represents is rate of change of y with respect to rate of change of x, right. So, what is delta y by delta x? How is the y changing with respect to x? So, in a realistic scenario, you can think about when you draw a line something like this, this is what we are talking about, delta y, this is the rise, increase, the rise in change to that of delta x, the change of x. Physically, if you have a mountain, then that slope of the mountain can be very well be expressed by this particular equation. So, you are not seeing it as a mountain, but you are seeing it as a line, a straight line with a particular slope. And so, if you then using that, you can decide if you want to climb this, how much of effort is required and all other aspects of it. So, these two things, okay, what we talk about it, these are what we call as the symbolic models. Okay. Either we are using verbal symbols or we are using mathematical symbols. Okay. With this, I hope you guys have understood and I have an overview of what is a model, what is the process of modeling, how is it related to the system, what is the boundaries of a system and how it helps in modeling, and what are the different type of models. And for each one of these cases, we mostly will be focusing on what we call as the mathematical models as part of analytics. Okay. We will see in the next class on some more advanced aspects of these analytics, or how the decision process in analytics are taken or considered together, and how analytics leads to different type of decisions and different decision layers what we covered yesterday, and then we will go from there. Thank you.